Okay, so here we're looking at graph of a function. Now the idea is knowing what a function is. Now suppose we have a function f of x equals to 3x minus 4, for example. Okay, so here's my function, and once again I verbalize it out one more time. This function name f is taking any input for x, any value for x, and then what it does to the inputs of x, what it does to the value of x is this function is going to multiply the value of x, any value of x, by 3 and subtract 4 to it. And so because of that, now we have learned already how to build a table representation for this function. So on this left hand side of the table, you can construct a column and putting in any independent values for x. So here I would choose, say, -2, -1, 0, 1, 2, and you can choose other values as well. On the right hand side column here is the list of the corresponding functions value after you evaluate at the specific input value. So now we have done this before, so here allow me to go quickly here, but so f of x value at x equals 2 would be minus 10, and here we have at f of x value at x equals -1 would be minus 7, and here I have a -4, and here I would have 3 times 1 would be 3 minus 4 would be -1, and then when I have 2 times 3 equals 6, and minus 4, that gives me positive 2. So now the idea now is that when you look at the table, each of the pair here exists as coordinates point. So I'm taking the whole pair here, and I'm treating that as a point on the plane. So here -2, I call that the x component, and -10, I call that the y component. So I have these points here. The first point is created by looking at the whole pair here with -2 for the x coordinates and -10 for the y coordinates. So -1, -7 give me another point, -1, -7, 0, comma -4, and here I have 1, comma -1, and here I have 2, comma -2. The idea of graphing is, now I'm going to go ahead and bring all these points with the given coordinates here. I'm going to put them on the graph space together with the axes. So now, if you're looking at my graph right now, and here's my x-axis and here's my y-axis. So the first point that we have would be -2, -10. So, and here's where we can locate it on the x and y system. -2 for x, -10, 4, 6, 8, 10, -2, -10. So that gives -2 is right here on the x-axis. Here's -2, here's -10. So right here at that point, you have a point right here at that meets with those two coordinates. We have the point. And now the next point, looking back at the table, -1, -7. So now my next point is -1, -7. So as you can see, how I'm making it aligning with the grids here on my graph. So that's my next point right there. So the first point, -2, -10. The next point here is -1, -7. The third point is a 0, -4. And so here it is. 0 on the x-axis, 0 is right here, and -4 is right down here. So there's my point. So this point, 0, -4. The next point up is 1, -3. So 1 and -3. So right there, 1 for x, -3 for y. Actually, I have it incorrect written down. -1, -1, -1. I'm sorry. So here's -1. So here's my point right there, actually. So this point is not true. It's not right. So I have 4 points so far, and the next point is 2, 2. So 2 for x, 2 for y, and there's wherever the two coordinates meet together, that's my point. So here 1, -1, and here 2, 2. So now, as you can see, if you observe the 5 points together, they seem to be lining up. And believe me, you can throw in more points in between these points, but now at least I can see that these points together, they start lining up and form some kind of shape. If you connect through the points here, they're forming some kind of shape. And so indeed, as if I can put in a ruler or something like that, and here you can see that these points nicely line up into a line. And so here I call that the graph for this function is a line. So this is the graph for the functions. So this is the graph for the functions f of x equals 3x minus 4. And maybe I'm going to zoom it out a little bit so that you can see, have a better view of the whole graph itself. So that's how we graph. So now generally the basic idea now is that whenever you start out knowing the function itself, if you know the function itself, you can always construct a table of values, or you can construct a table representation of the function. And now the table, each row of the table represent a point, and you treat those points as a point on the space, on the graphing space. So, and then you can always line up those points, and there you create for yourself the graph. And that's basically the idea of how we graph. The whole point of looking at the graph now is that in 2.1, you also learn how to be able to determine a function's value. So now suppose I'm giving you a different function. Here, what I have here in front of me is just simply some kind of function, f of x. And the graph for that function is given right here, but this time I really do not know what the function's value is. I mean, I don't know the function's formula is. But now the question is asking me, find, say for example, if I'm writing on this, the question is asking me, find f of 1. Okay, so the notation here, once again, if we look back into the class lecture, f of 1 means the function value, the functions at x equals 1 equals to which value. So we need to find the function's value at f of 1, at x equals 1. And so each point along the graph here, for any point along the graph, the x coordinates of that point would be the inputs of the functions. And then the y coordinates corresponding to that point would be the function's value at x. And that's the whole basic idea of graphing. And so taking on to that idea right there, f of 1, so now you're going to locate, 1 is right here on the x-axis, 1 is right there. So f of 1 would be, you're going to write at 1, you're going to draw a dashed vertical line, drawing it up until wherever it meets with the actual graph itself. And so right there, measure for yourself what is the y value corresponding to that. And that y value would be the answer to those questions. So now if I measure, oh, and of course we are supposed to eyeball these values right here, because reading off the grids can be hard sometimes. But here I'm seeing that for my y value, right at x equals 1, my y value would be 1, 2, 3, 4, and 5 square grid above. So my answer to f of 1 would be equals to 5. And so that's how I can find a functions. So 5 right here is the function's value. Okay, and the 1 right here would be the x value. Okay, so now similar question. I can ask again. We want to find, how about f at x equals -3. Find the function's value of x equals -3. So now when you're looking at that notations, and when you're looking at the questions like that, on the x-axis, if you have the graph, then on the x-axis, where is -3? Right here is -3. And once again, draw a dashed vertical line and keep drawing until it crosses with until wherever it hits the line of the graph. There is that point. So how much y value is this? That would be +2. So the answer to this would be +2. And that's how we find the answer to that second question. Okay. And so one more question. What happened if we were being asked, find, maybe on the other space of the graph here. So this time, how about we are asked to find f of 5. Okay, so now once again, the easiest way to go is the 5 is representing the x value that we put into the function. So now you're going to, on the x-axis here of the graph, you're going to have to go 1, 2, 3, 4, 5 on the positive way, and then draw for yourself vertical dashed line until wherever it meets with the x-axis, it meets with the graph itself, it hits the graph, and right there, how much y value is this? And so how much vertical coordinates is that? And what either way I'm counting, 2, 4, 6, 8. So the answer to that, to f of 5 equals 8. So that is also one way how you can evaluate a function's value based on the graph.